we have all the necessary inputs. We have the KLH panel, so we have 180 millimeters from KLH, as I mentioned. We have forces in the direction of the connection and perpendicular to the connection, and we'll start with half-lap width of 100 millimeters, and we're going to use Eurotech screws with supplier's ETA. So, and I'll add a half-lap calculator here. We can start editing. And here we can start with the design. So first we have option for selecting the code. So we have Eurocodes pre-selected. For supplier, we're going to select again KLH 180 of 5 layers. For the lap width, we can start with 100, as we mentioned. And also we have option for selecting floor type. So it can be either discrete or continuous. So if you want to design 1 meter strip, as we're going to go, we can select only continuous one. While if you want to check also what is the number of fasteners you needed for your connection, you can type in discrete and input the total length of the connection. We have option for also dynamic imagery. So we have top view, section A, section B, and we'll soon select the CLT, the connection supplier, so the appropriate screw with it. So we'll select Eurotech, as we mentioned. For the screw family, we'll select partially threaded screw washer type, and we'll go with the same screw as we used on the diaphragm design. So we can type in a panel twisted 6 by 160, and this will be automatically updated on dynamic imagery as well. And for the analytical methods, we have option for selecting either Eurocode or supplier's ETA calculation. So it's for all these methods, we have option always with ETA, and we always recommend that you use that in calculation, because more precise information from each supplier included, including rope effect calculation, intermediate edge distances, and specifics with the products and tip types. So that's also something that you can find with more information. If you want to check out what are the differences between some specific calculations, also worth mentioning that we have also, beside the current, we have implemented the new Eurocode. So I'm about to show you that at the end of the calculation as well. But for each type of calculation, there are some differences in shear, actual capacity, also for the incline and spacing of the screws. So that can be also important and can affect your design with some nuances, especially if you're short with the geometry and have specific inputs. For the screw geometry, we have a flush with member face, but also there are some options where you can put it with custom embedment length. We'll keep it vertical, but note you can also use incline and crossed. For spacing along, we can type in 150 as we have started, but this is represents an iterative process between the diaphragm and connection design. So this is something that we can only start with. For loads, we'll type in 8 by 86 as we have in the design, and 6 by 76 as a force that is applied perpendicular to the connection. For the design data, we have 1.3 for gamma. Load duration, we're going to pick up long term. As for wind loads, service class will keep 1, and pre-drilling will set no. So we started with inputs. We can see that geometry check is okay, but we know that the shear capacity is not proper. So we have option either to increase the diameter of screw, either to increase the spacing. So in this case, we can type it with lower spacing, 120. This is still not enough, so let's keep to 100 and see if this can help. So we can see that 100 millimeter distance between screws is something that we can use. Also, just to show you a preview between the results. So if we change back to Eurocode, we'll see that there's some difference in the results. So it's not too much, but that sometimes this can help to have a connection that can satisfy the requirements or not. Also, just a preview for the new Eurocode. So if you go back to the design code, you can switch between the current and the new Eurocode provision. If you go with the new one, you'll see that you have more conservative results in the new Eurocode verification, and that these for example, 100 millimeters will not be enough according to draft version of Eurocode 5. And in this example, we can stick with the ETA and the current Eurocode. And just a preview of results, we have information about the screw geometry. We have also lateral capacity, so rope effect calculations. Then we have characteristic axial capacity of the screw. Then all the timber failure modes are listed here. So if you're interested, you can check all the numbers in details and trace the calculation where is something that can be interesting to you. But also in the here, if you scroll down, you can see the summary of all failure modes, what is the lowest capacity, and also what is the effective numbers of the screw in the end. What is the shear capacity of the connection with all the references for each step as well. So we can go back, we can save this calculator, and we can go to the next